What we're going to look at here is just an example of the chain rule. Okay, so there's really not a whole lot proof going on here. I'm not proving anything. All I'm doing is I'm just giving you one example of how this idea of the chain rule works. Okay, so this is an example, not a proof. So let's say for example we had some function g of x. I don't know what it is. Let's say it's equal to 2x plus 7. And then I wanted to take a look at a new function, which was h of x, which is going to be g of x squared. Okay. Now that would be equal to 2x plus 7 squared. Okay. Now the question is, how do we differentiate this guy directly without having to do all the multiplication out? Okay. So it could be something much worse. It could be something like, what is this to the 10th? Well, now if you sit and you have to multiply this guy out 10 times and then differentiate that polynomial, you're going to be here for a while. Okay. So let's just say this. Let's say we've got some new function. Okay. And we want to g of x, I don't know exactly what it is, but it's squared, and I want to find the derivative of it, so with respect to x. Okay? Now how am I going to go ahead and do that? So what we're going to do is we're going to differentiate this. Okay? So if we go ahead and differentiate that, I'm going to go ahead and use the product rule. So we have d dx of g of x times g of x, like this. So that is going to be the derivative of the first guy times the second guy plus the derivative of the second guy times the first guy. So that's going to give me the following. So this one right here gives me g prime of x times g of x, and the second one gives me g prime of x times g of x. And so what I end up getting is 2g prime of x times g of x, just like that. Okay? So we could go ahead and we could do the same thing for a higher power. But what I want you to notice is this is equal, if I just rotate terms here, it's equal to the derivative of g of x squared by pretending that g of x is my x variable. So what I mean is, like, if you had just x squared and you differentiated that, you would get 2x. So what we're saying here is if you have g of x squared and you differentiate that, well, you get to g of x, but then you also get this extra little term here at the end, which is g prime of x. Okay, so this is going to be part of the chain rule where we're going to be able to differentiate the, we'll say, outside of the function and then take the derivative of the inside portion. So if I want to differentiate this, what I do, take the derivative, is I drop the 10 out front. I leave the inside guy because that's the original function. Okay, so I've differentiated it, but then I have to multiply it by the derivative of this inside piece here, which is 2. So this is 20 times, 20 times 2x plus 7 to the 9th power. That's your derivative. And that's the chain rule, and that's what we're going to go ahead and work on. Now, we can also apply the same rule for differentiation if we have, like, maybe a higher power. So now watch. What if I have d dx of, let's say, f of x to the 3rd power, like that? Well, again, I can look at this like the following. I can look at this like f of x times f of x squared. And so if I differentiate, I should write this notationally correctly. So if I differentiate this, the product rule gives me derivative of the first times the second plus the derivative of the second. Now we know the derivative of this is going to be 2 f of x times f prime of x. Okay, that's the derivative of this guy times this guy. And so this will give me f prime of x times f of x squared plus, okay, now it's going to give me 2f of x squared f prime of x. And notice that I've got the same thing in both those. So I've got 2 here, 1 here, so I have 3 of them. So if I just rearrange my terms, there it is. Okay. Now we can go ahead and we can do this. We can prove for the power rule, we can prove the chain rule, which is what we're using. For the power, as the power rule we'll call it, okay? Basically the power of a function by induction. Okay. So how much time have I used? 6 minutes. So I'll go ahead and leave that up to you. But it's exercise 52 in the book, and it may be a nice question for you to spend some time looking at.